Oh, that's good. Okay, let's go. So the topic this week is on gradient descent and sort of a small bit of backpropagation in relation to just the small overview knowledge. So quick overview we'll go through is derivatives, gradients, stochastic gradient descent, and then chain derivatives, which is the process of backpropagation. So derivatives should be pretty strict and clear. It's if you take cap one, it's just the how much change occurs in a function, so how much rate of change depending on different various inputs to the output. So I'm just going to skip over this one. And then more importantly, gradients is the application of derivatives, but to a more generalization of how many dimensions the actual function is on, where you'll be considering your x as inputs and y as the target values. And then because we're also learning, you also need to be learning, it's going to have a matrix of the different weights. And then also the prediction value is what you'll calculate using some of the built-in dot product functions. And then the loss is just going to be the difference between the actual target values and the prediction values. And then you'll always start off at your initial weight, so your starting weights. So weight zeros or weight underscore subscript zeros. And when you apply so when you're doing gradients, you can apply built-in gradient functions, and this will return back a matrix of the differences between the actual target and predictions. And then what you want to do is you want to apply these further into adjusting these weights, so you'll apply on the learning rates multiplied by one of the gradients for each corresponding point inside of the matrix of weight values. So like if you're at gradient of 0, 0 is going to go to 0.00 inside of the weight matrix as well. And then when you're actually working on something like this, TensorFlow itself offers various functions to actually apply a gradient on, or various options. So one is that if you can build a minimizing function that you want to actually apply on, and then after that you'll create a like a optimizer class from TensorFlow itself, and then most likely you'll use something like SGD or stochastic gradient descent, and then that will just require you to input one of the learning rates that you want to use. And then to actually use it, you can do something like, to actually calculate your individual gradients, you can do something like optimizer class minimize, and then the function you want to use, and then the list of variables that you're actually applying on. And then this will get and return to the each individual gradient value as it tries to actually minimize the difference. Gradient tape is an option you can use if you want. And then within stochastic gradient descent, so what we're going to do is you actually take a batch of your inputs, x, and your target's output, y as well, and then you just run those through your network to actually obtain some of your prediction y's. And then next after that is going to be actually taking the difference. And then finally, you'll be applying on your gradient with the learning rate to actually adjust each individual weight values within the matrix at, since the matrix is going to be 2D matrix, you'll just be applying gradient from point ij into weight matrix point ij as well, whatever corresponding I and j indexes. if you're actually going to run it. So this example here is just doing a network through using the MS data set as the disk we'll be working with. So the parts to really highlight here are here, which is already added, which is from earlier, how to make layers and how to actually make a network out of it. But then what you want is your optimizers, your actual application of the gradients. So within working with TensorFlow and Keras, you have your network class, and then that actually has a compile function which will require you to specify what type of optimization function you actually want to use, and then what type of loss function or like the difference function you actually want to use as well. That'll depend, and that will really just be on your knowledge and your knowledge situation. And then what those will do is they'll actually run it, and then you'll also be going through reshaping and specifying out the actual data types you'll have in the networks for most of all. But with Keras, that's pretty much what the actual workflow is if you're actually going to be training with it. And then training a network using the different types of gradient descent functions. Now, while that works, there's actually also another way to do it as well, which is a mix of TensorFlow and Keras when you're actually applying some of these gradient descent functions. So I'm just going to run through and then point out some specific bits to actually really consider here. So here's neural networks, here's your actual net that you create within layers. That doesn't really change that much with the call or your actual forward pass. So like the one actually the first time you're actually going to go through and then take some prediction values. These are just the loss functions you can define as well. You go through defining depending on situation. What really we have is that you can, one way to do it is you actually go about making a optimization function that will actually use TensorFlow's built-in gradient functions to actually calculate different gradients. And then what this actually does is now that you have your predictions, you also have your gradients to use as a way of calculating out the differences and applying those. So what you end up with is here there's trainable variables that it just defines and specifies which variables to actually work and train on. Here gradients will actually take out the gradient values from based on the loss function and then based on the actual variables you're working with. And then finally, optimizers. So TensorFlow optimizer objects have a function to actually apply the different gradients onto said variables as well. And what's happening is that these different functions will get used to actually apply the various learnings and adjustments that are going to be made. And this is also kind of how, since these actually also have the fitting and the learning will also be included inside, we'll also include the actual backpropagation as built-in functions as well. So this is why we aren't going over the exact details and the exact implementation of the backpropagation algorithm. This is just as is. But what essentially backpropagation is its way of actually chaining together the different derivatives. So for math, this would be applying the chain rules as to apply each individual derivatives onto finding the actual output values as well from each individual layer that comes afterwards onto the previous layers.